NASA shared new revelations today from the James Webb Space Telescope, the largest space observatory ever made. They say they have found a significant sign of possible life beyond our solar system. They've done so by detecting the chemical footprint of gases in an exoplanet's atmosphere. When the James Webb Space Telescope pointed its colossal gold-plated mirror toward a distant region of space, roughly 120 light-years from Earth, what it found defied expectations. Amid the familiar gleam of distant starlight and the softly glowing scatter of nebulae, the telescope captured something striking. A clustered array of light signatures displaying regular pulses, patterns, and spectroscopic anomalies that bore a resemblance to artificial illumination. These weren't erratic flares of cosmic gas or reflections from icy moons. These lights flickered in rhythm, held a structured layout, and hovered in gravitationally unlikely locations. Scientists paused, then rechecked. After hundreds of calibrations and cross-checks, the data remained consistent. The James Webb Space Telescope had possibly observed something akin to structured illumination, persistent and artificial, from a point in interstellar space. Please engage with this content responsibly and share your thoughts in the comments below for more updates. The implications rippled immediately through the astrophysics community. This was not an ordinary find. Structured illumination, situated 120 light-years away, would mark a historic first. The direct observation of what could be technological activity beyond Earth. The object's distance places it well beyond the Kuiper Belt and the solar system's outer edges. At 120 light-years away, it sits in a region once presumed to be silent, dark, and lifeless, inhabited only by rogue planets and the frigid outskirts of cosmic debris. Yet here, James Webb detected sustained lighting activity arranged in geometric precision. What appeared to be an array of grid-like illumination shimmered in the infrared spectrum, precisely the domain where the telescope excels at unearthing the subtle fingerprints of stars, gases, and potential biosignatures. Urban lights on Earth follow a distinct pattern. Their glow varies between yellowish sodium arcs, bluish LED grids, and the soft scatter of ambient emissions. What the telescope observed mirrored those familiar traits, but scaled astronomically. It was like looking at a planetary surface, or perhaps a colossal orbital structure where light was being emitted not by nature, but by engineered systems. The configuration seemed deliberate. Patches of dark and light alternated in patterns suggestive of roadways or power distribution networks. There was no mistaking the grid-like alignment, and it shifted slightly, but with continuity. Over the days and weeks of observation, the light patterns fluctuated in what seemed to be a cycle, rising and dimming in periodic harmony. Not only were these lights detectable, but they were persistent, structured, and mathematically precise. No natural formation quite explains this. While certain reflective minerals and ice-covered surfaces can generate luminous anomalies, they lack repetition and the deliberate sequencing this source exhibited. Furthermore, the emissions aligned with specific infrared wavelengths, known to correspond with high-efficiency energy use, similar to the light signatures from advanced energy systems. The notion that these emissions are merely coincidental outcomes of rock and gas behavior quickly fell apart under spectroscopic scrutiny. These weren't solar reflections or auroral bursts. These were emissions controlled, repeated, and patterned. And that, perhaps, is what makes this discovery so staggering. This detection pushes the boundary of observational astronomy into uncharted territory. Historically, humanity has peered outward in search of biosignatures, signs of life indicated by atmospheric imbalances like methane and oxygen. We've scanned for radio transmissions, optical pulses, even Dyson sphere-like heat signatures. But the observation of apparent structured illumination in interstellar space bridges science and science fiction in an unprecedented way. It shifts the paradigm. Instead of waiting for a signal or a leak from some extraterrestrial broadcast, we may have found the quiet evidence of infrastructure, an engineered structure casting its glow across the darkness of space, inadvertently noticed by our most sensitive eye. To understand how James Webb detected such lights, one must consider the telescope's unique capacity. Operating primarily in the infrared range, Webb can see through gas clouds and dust, revealing hidden galaxies and the chemical compositions of faraway worlds. But infrared light also captures heat signatures and low-energy emissions, like those given off by warm cities on a planet's night side, or by heat-conserving structures in deep space. The source observed was not emitting intense thermal radiation, but rather stable mid-infrared patterns indicative of technology adapted to cold, low-energy environments. It's as if the light wasn't meant to broadcast, but simply existed, like a distant city glowing in the night, unaware it was being watched. What's especially riveting is the scale of this phenomenon. The source area spanned several hundred kilometers, assuming a planetary surface, though there's ambiguity as to whether this light emanated from a planet, a moon, or perhaps even a free-floating structure like a mega-satellite habitat or an engineered station. The spatial resolution of Webb, though extraordinary, leaves room for interpretation. Nonetheless, the luminosity distribution wasn't scattered. It bore spatial cohesion. There were hubs of intensity, zones of dimmer scatter, and directional changes consistent with orientation relative to a stellar source, perhaps adjusting to receive or shield from solar input. One of the implications of this discovery is existential. If structured illumination exists 120 light-years away, they did not just pop up recently. The light observed is already 120 years old, delayed by the tyranny of cosmic distance. The civilization responsible, if such a civilization exists, could be either flourishing or long gone. But the light remains, evidence frozen in transit, arriving now to tell a silent story. And this 120-year-old beacon suggests that whatever intelligence engineered those lights had mastered energy management on an extraordinary level. For their light to be visible across a light-year's gap, even in the subtle tones of the infrared, implies technological scale orders of magnitude beyond human industry. Another question emerges. Why there? That part of space isn't special. It lies along no major stellar route and harbors no known exoplanetary systems. But this itself is telling. Advanced civilizations may not prefer crowded planetary systems. They may colonize or build in the outer cold, free from gravitational noise or solar volatility. Perhaps this cluster of lights belongs to an artificial world built where isolation ensures stability. Or perhaps it is mobile, orbiting some now extinct stellar core. The absence of accompanying radio noise deepens the mystery. These lights do not communicate, not in any way our instruments can detect. They simply shine. Then there's the technological implication for humanity. If what Webb has observed is indeed a form of structured illumination, alien or otherwise, it confirms something many have only hypothesized. that light in its most basic expression might be the oldest and most universal form of footprint a civilization can leave. Long after buildings fall, atmospheres dissipate, and societies rise or vanish, the echoes of their light can drift across the interstellar void. This brings urgency to the field of technosignature research. Light, structured and sustained, may be a far more reliable marker of civilization than any signal or artifact. A civilization might hide its broadcasts, encrypt its communications, or cloak its frequencies. But hiding light, especially when used on a massive scale, may be a challenge even advanced engineering cannot fully solve. What also stirs the imagination is the potential for structured illumination as a deliberate signal. Imagine a species that has grown tired of sending messages into the void. Instead of broadcasting, it simply builds in a way that makes itself visible to those with the eyes to see. The grid of lights could be the ultimate passive signal, an open invitation not to communicate, but to recognize. A cosmic gesture of presence saying, not we are calling, but we exist. That possibility alone reshapes the entire conversation about first contact. It may not come with a message, but with a glow. The discovery also challenges long-held assumptions about the cosmic silence humanity has endured. The so-called Fermi paradox, the contradiction between the high probability of alien civilizations and the lack of evidence, might finally be dented. Perhaps the universe was never silent. Perhaps we simply weren't looking in the right spectrum, or with instruments sensitive enough to detect the quiet signature of daily existence rather than the rare blare of interstellar radio. Structured illumination isn't loud. It doesn't shout across the stars, but it remains. It lingers. It glows like embers in the dark, overlooked by those expecting a beacon. Equally fascinating is the biological implication. Structured lighting implies long-term stability. A civilization cannot construct an infrastructure capable of emitting detectable light across such distances without having overcome basic environmental volatility. It suggests governance, energy discipline, and, most importantly, time. Whatever species produced those lights has likely endured cycles of history, technological evolution, and perhaps planetary transformation. They've learned to manage their energy systems to such precision that the waste heat alone radiates a consistent and interpretable pattern. This is not the work of a nascent culture. This is the product of maturity. The James Webb Space Telescope, built to peer into the earliest epochs of the universe, may have accidentally stumbled upon a revelation closer in scale and relevance to us. While it routinely analyzes galaxies billions of light-years away, this discovery, 120 light-years distant, is emotionally and practically closer to home. It feels attainable. It turns the idea of cosmic neighbors from theoretical abstraction to tentative reality, and it invites new missions, new eyes, and new thought. If lights flicker there, they might elsewhere. If this was the first discovery, it might not be the last. There's also a philosophical shift underway. For centuries, humanity has imagined that if alien civilizations were out there, they'd reach out. But perhaps the cosmos operates under a different logic. Presence doesn't necessitate contact. Structured illumination might be the default endgame of intelligence. Energy, shaped into form, not necessarily made for others to see, but visible nonetheless. And in that idea lies a humbling truth. In our own cities, our street lamps and skyline glows radiate outward, unnoticed by us, but traceable by others. We too leave light behind us, not as messages, but as artifacts of our existence. The structured illumination, 120 light years away, may never yield their origin. We may never visit, may never decode them, may never know whether they're ancient ruins or thriving hubs. But the discovery itself changes the lens through which we view the stars. Each point of light is no longer just a sun or a planet. It might be a window, a city, a statement. And thanks to the James Webb Telescope, we now understand that in the deep, cold silence of space, even a single flicker can redefine everything. The realization that structured illumination exists 120 light years from Earth doesn't simply rewrite what we know. It opens entire new disciplines of thought. This is not a tale of simple discovery. It's a confrontation with the unknown, the beginning of a dialogue with silence. One of the most profound shifts emerging from this observation is the way we think about infrastructure beyond Earth. Until now, even the boldest science fiction has centered on planetary civilizations, worlds that evolve like ours, with cities clinging to continents and lights following coastlines. Yet, what Webb saw was not tethered to a known planet, nor associated with any familiar stellar system. The implication is staggering. Infrastructure may not need planets at all. Instead of a civilization growing from the soil of a nurturing world, it's now plausible to consider life, and intelligent life, originating or migrating to structures suspended in interstellar space. These may be engineered habitats, fully artificial worlds, or even distributed platforms designed to harvest energy from the emptiness, freed from the gravity wells and ecological risks of planetary environments. Such societies may find stability not in the warmth of a sun, but in isolation and controlled engineering. This could redefine what a habitable zone means. No longer limited to the Goldilocks distance from a star, habitability might be found in technological mastery, in the ability to build warmth and light where nature offers only cold and shadow. This vision doesn't only stretch scientific imagination, it refocuses practical engineering. The structured illumination observed hint at something more than just illumination. They suggest power transmission, heat regulation, and possibly even motion. There is reason to speculate that these lights are affixed to a structure capable of orientation, perhaps even mobility. That opens the possibility of a nomadic civilization, one that traverses space not as explorers, but as dwellers, voyaging without destination, adapting their environment as they go. They may not colonize planets at all, but instead design living systems in modular architectures, expanding like coral across the dark sea, driven not by conquest, but by continuity. What kind of technology would such beings employ to maintain illumination over a scale detectable across a light year? The energy demands would be immense unless their systems operate with efficiencies that defy our current benchmarks. That prompts the consideration of post-thermal technologies, systems that might manipulate gravity, bend space-time, or generate energy through mechanisms entirely foreign to us. Perhaps they've developed methods to produce light without heat, or to convert cosmic radiation into structured glow. Their lights, then, are not merely visible. They are intentional byproducts of a mode of existence far more advanced than ours. Just as early humans learned to channel fire into lamps and lanterns, this civilization may have learned to orchestrate photons in space itself, forming a lattice of luminescence not out of necessity, but out of design. There's a haunting beauty to the idea that those lights, quietly shining for years across the void, are older than any war we remember, older than the digital age, older than our space probes. They've been out there unblinking, awaiting the moment that one sharp-eyed observer, floating a million miles from Earth at the L2 point, would happen to glance their way. This timeline realigns us. It reminds us how young we truly are, not just biologically or culturally, but in the sense of perception. Only now, with instruments like Webb, do we even possess the means to detect what might have been waiting in plain sight for eons. And if we take the evidence at face value, this light source is not broadcasting, not hailing us, not issuing a call. That too may be deliberate. Perhaps it reflects a civilizational philosophy we can barely grasp, one where visibility is not intrusion, but inevitable presence. Imagine a culture so old that communication across light years is no longer appealing. They've accepted the vastness of space as a filter. Only those advanced enough to see the glow are advanced enough to understand it. Communication becomes implicit. Message becomes existence. This reframes the SETI initiative, the search for extraterrestrial intelligence. For decades, radio waves and lasers have been humanity's chosen instruments of cosmic conversation. But those tools, limited by distance, direction, and the transience of signals, may miss what is quietly present and persistent. We've been listening for shouts in a galaxy of whispers, searching for a pulse when a glow might suffice. The James Webb discovery suggests a broader method, searching for enduring light patterns as indicators of life, not just transient bursts. The idea is both ancient and new. Light is the first thing any being controls in the dark. We're just now learning to read that control as language. Structured illumination isn't static. Its rhythms echo the functions of life: movement, consumption, change. If those lights are truly indicators of a living habitat, then their variability could offer insight into the daily patterns of the beings that reside there. Perhaps what Webb saw is their night, a phase when energy shifts from external tasks to internal rhythm. Or perhaps it was their equivalent of a day, the peak of activity. More tantalizing still is the idea that the variations in the light pattern could carry intentional encoding, not a direct message, but a display of order, structure, even culture. The spatial geometry of the lights deserves careful consideration. They were not arranged randomly or amorphously. The detected shapes seemed linear, orthogonal, grid-like. Such arrangements, absent in nature at large scale, are strong indicators of engineered planning. On Earth, urban layouts emerge from geometry: streets, blocks, lighting grids, transit paths. To see similar structures from 120 light-years away suggests a common solution to the challenge of shared space. Geometry may be a universal expression of intelligence, a way for consciousness to impose pattern on entropy. That Webb captured this geometry at all speaks to both the scale of the structure and the precision of the instrumentation. And what lies behind that geometry could be governance, logic, perhaps even an aesthetic sensibility. They may build their light in ways that please them. In that possibility lies something deeply human. Light is also a medium of security. On Earth, we illuminate what we wish to protect. Streets are lit not just to guide, but to guard. Facilities, perimeters, and homes are bathed in light to push away the unknown. If this civilization employs light in a similar fashion, we might be glimpsing a layer of their emotional logic, their fears, their priorities. Or perhaps their lights serve as cultural markers, illuminating monuments, transit hubs, or centers of learning. Without language, color, or motion to decode, we are left with the simplest reality. They chose to make light. And that choice is profound. What if we've only seen the edge, the outskirts, the distant glimmer of something far vaster? A single frame of Webb's instruments might have caught just a corner of a continent-sized structure or one node of a vast stellar web. If these lights are part of a distributed array, then the full scale of the civilization might stretch far beyond our current field of view. We may be peering through a keyhole into a sprawling galactic infrastructure. Lights as outposts, beacons, or stepping stones of interstellar migration. Another layer of implication concerns time. The delay between the emission of that light and our reception of it means we're not seeing the present, we're seeing the past. In this case, a delay of 120 years. But as instruments become more powerful and capable of deeper observation, we'll encounter civilizations not as they are, but as they were. Our whole relationship with intelligent life will be asynchronous. First contact won't be a conversation. It will be a study of fossilized presence. Lights flickering from the past become our only interface. If we respond, our message too will be delayed, arriving only after years or centuries, perhaps to a civilization that has moved on or vanished. Despite the technological grandeur implied by this discovery, the emotional response it elicits may be even more important. Awe, wonder, vulnerability. We are no longer looking into a void. We are seeing, possibly for the first time, the signs of those who came before, or those who dwell apart. This moment reintroduces mystery into a scientific landscape that has become, at times, overly deterministic. Webb's detection reminds us that the universe is still full of surprises and perhaps full of neighbors. In practical terms, this discovery could pivot global priorities. Agencies focused on exoplanet research may now look deeper into space for similar light anomalies. The funding for passive light observation arrays might increase. New mission profiles will emerge. Missions that don't just search for habitable worlds, but search for artificial night. We may see the launch of probes designed to map interstellar light pollution or to follow up on regions identified as potential technostructures. The age of waiting for messages might shift into the age of reading light. And what of Earth? If light is visible across light years, then our planet too has been radiating its presence since the invention of the light bulb. Our city lights, reflected by satellites and diffused through atmospheres, have painted our location into the sky. We've been writing ourselves into the cosmos without even knowing it. The discovery, 120 light-years away, may only be the first of many such signatures. We may soon realize we are surrounded not by beacons or ships, but by evidence, by trails of light, left like footprints on cosmic shores. In all this, one chilling question lingers. If we can see their light, can they see ours? Are we already under observation? Did our glow, however faint, reach their telescopes years ago? Are they watching us now as we watched them then? Our light just a curiosity to them, or perhaps a signal worth interpreting? If they exist, and they are as advanced as their apparent architecture suggests, they may have seen Earth bloom into brightness. They may have charted our growth, our expansion. Perhaps we are not the discoverers, but the discovered. In that line of thought lies humility. For all our technological triumphs, we remain young, only just now lifting our heads to see the universe not as a canvas, but as a city, a network, a light with presence. The lights 120 light years away remind us that we are not alone in using energy to shape the dark. Others may have done it long before us. Others may be doing it now. From here, everything changes. The search for life is no longer about whether it exists, but about how often it chooses to be seen. The structured illumination spotted by Webb is not a conclusion, but a doorway. Through it, new questions emerge. How do civilizations evolve in deep space? What do they fear? What do they value when the stars themselves are silent companions? What does it mean to build a home among dust and distance? And perhaps most poignantly, what does it mean to be seen across a void so vast that even light trembles in its journey? As we develop sharper instruments, expand our arrays, and send probes farther, we may discover that lights like these are not rare, but common, not anomalies, but normalities. The universe then becomes not a wilderness, but a constellation of cities, each glowing softly, carrying stories we may one day learn to read. The James Webb Space Telescope did more than detect a signal. It lifted the veil. It showed us that even in the coldest corners of existence, warmth persists, not as accident, but as artifice, as will, as proof that someone somewhere turned on the lights. The appearance of structured lighting in deep space, 120 light years away, forces a reevaluation of how and where civilizations might thrive. The traditional assumption has been that life emerges near stars where warmth and energy are abundant. But what if intelligence has adapted far beyond that cradle? The light captured by Webb may come from a post-planetary civilization, one that has long since left its home world behind, seeking stability and control in the outer dark. There, free from solar radiation storms, orbital clutter, and planetary cycles, they could build